Hey guys, I hope you guys are doing well. So welcome to the AS paper for the Edexcel A-level maths, statistics and mechanics paper. So normally these papers are in two documents, so I do separate videos for both. But for this one, I just thought I would merge them and just see how the retention works for YouTube Studio, to be honest. So yeah, it's one video instead of two this time. But yeah, timestamps will be in the description, so you can go to whatever section or whatever question you need to. The first half will be stats. The second half will be mechanics. The past paper will be on my website as well for you to try. And yeah, that's pretty much it. To be fair, we're pros at these walkthroughs now, so there's not much that needs to be said. So let's get right into it. Okay, so question one says a coach recorded the heights of some adult rugby players and found the following summary statistics. The median is equal to 1.85 meters, that's my height. The range is equal to 0.28 meters. The interquartile range is 0.11 meters. The coach also noticed that the height of the shortest player is 1.72 meters. 25% of the players' heights are below the height of a player whose height is 1.81 meters. Draw a box and whisker plot to represent this information on the grid below for 4 marks. Okay, so box and whisker for the first question, not too bad. Essentially, we need five things, don't we? We're going to need the smallest value. I'll just write S for smallest value. We're going to need the lower quartile. Then we'll need the median. Then we'll need the upper quartile. And then we'll need the largest value. Once we know all of these, we can then draw our box and whisker plot. So firstly, what do we know out of these? The median is 1.85, so I can put that there. Do we know anything else? The height of the shortest player is 1.72, so that will go there. Anything else we know? 25% of the players' heights are below the height of a player whose height is 1.81. 25%, that's the first 25%. That must be the lower quartile, isn't it? So 1.81 must be the lower quartile, so I can put that there. Okay, so now it's our job to figure out what the upper quartile is, what the largest value is, and then we can uh, draw the box and whisker. So let's start with this information of the range. The range is 0.28. Now we know the range is the largest value minus the smallest value. So what I can say is that, well, L take away S has to equal 0.28, right? Now we know what the smallest value is. It's 1.72. So that just means I have L take away 1.72 is equal to 0.28. Add that on, that tells me that 0.28 plus 1.72 is the largest value, which is 28 plus 172, which is 200. So 2.00. So the person is 2 meters tall. That's a tall person. Okay, so that's L. Now the upper quartile. Again, we can just use the interquartile range information because the lower quartile minus the upper quartile, sorry, minus the lower quartile is the interquartile range. So I'll do it here actually. So I'm going to just say then that the IQR is equal to the upper quartile minus the lower quartile, and this is equal to 0.11. Yeah. So with that being said, that means that I've got the UQ minus the lower quartile, which is 1.81, must equal the 0.11. So therefore, the upper quartile is going to be 0.11 plus 1.81, which is 1.92. So that goes there. And now we have all of the information needed to draw the box and whisker. So I'm going to draw it. Now, by the way, just as a quick side note, OneNote, the software I'm using to actually do these questions and actually draw and write and stuff, they've actually updated it. So it's a bit tricky for me to now draw straight lines. So I'm just going to do it freehand. But obviously in an exam, you'll use a ruler, wouldn't you? So, okay, 1.72 is, it goes up in 0.01. So that's fine. So that is going to be over there. 1.72 is going to be over there, and then 1.81 is going to be over there, isn't it? Like that. 1.85 is in the middle, like that. 1.92 is going to be 2 after 1.9, which is there, and then 2 meters is obviously there. And then now we just literally just draw the box like this, like that, and then obviously draw lines like that. And that is essentially our answer. Now, again, use a ruler. I'm not using it here just because it's a bit tricky. Because if I try and use a ruler like this, I can't really rotate it with the laptop that I'm using. So I'm just going to not use it. So yeah, that is your answer. Again, use a ruler. And that's it. Question one finished. Okay, so question 2 says Keith is studying the variable daily mean wind direction in degrees from the large data set. Keith summarized the data for Camborne from 1987 into four directions: A, B, C, and D, representing north, south, east, and west in some order. So we've got the directions at the top: A, B, C, and D, and we've got the frequencies 22, 48, 56, and 58. Part A says, using your knowledge of the large data set, giving a reason which direction A represents, and this is a one marker. Now, the large data set, everybody's favorite part of A-level maths. So with this topic, essentially, they just want you to basically have a general understanding of these types of questions and the bits and bobs of the data. So what I'm going to do, which I did with the last walkthrough I did for the 2023 paper, is I'm actually going to go through a bit of the data to answer the question. But obviously, you're not going to have the data in the exam, so I really don't know what they want you to do. But anyways, let's read the question again. Using your knowledge of the large data set, state, given a reason, which direction A represents. So as we can see from the table, right, A happens to be the least frequent. So the question is, which direction is the least frequent in Camborne in 1987? So what I'm going to do is I'm just going to show you the large data set, which is here. It's an Excel spreadsheet. It's a very good spreadsheet. It summarizes everything on the first page, and then you've got the tabs for the different pieces of information. Now, to answer the question about the least frequent, what we're going to do is we're dealing with daily mean wind direction. And it says here that the daily mean wind direction is averaged over 24 hours on the day, and it's rounded to the nearest 10 degrees. And there's something else, I think it was here that I was looking for. Um, Anyways, okay, let's go to the next tab. So Camborne, May 1987, May to October. So this is the piece of information for it. Remember, we're looking for the least frequent direction. So we're going to go to this one here, cardinal direction. And as you can see, it's pretty much dominated by north, isn't it? North, northwest, and so on and so forth. And as you can see, just from a brief scan, the least frequent one is E, isn't it? It hardly comes up. So just based on that, the answer has to be east, isn't it? So that would be the answer for part A. So again, I'm just going to go to my here, and then I'm going to say A represents east, since this is the least frequent wind direction. In Camborne, just from the large data set, let me write this. Winds are typically from north, south, or west. And apparently they want you to know that, because the only way I was able to do is by looking at the actual data. So yeah, that is the answer for part A. So again, I would just recommend just maybe have a look at that document. If anybody wants the document, then just drop a comment and I can send it to you, or maybe I'll put it on my website, maybe. But anyways, yeah, that's part A. Part B, it says the entry for Hearn on the 27th of September 1987 was 999. State, given a reason, what Keith should do with this value. Okay, so remember, we're dealing with the daily mean wind direction. Now, again, what I would recommend, I've actually got a couple of documents here, PDFs, I should say. This is actually from the book. Just have a general understanding of each of these different variables here. So, what does it say about daily mean wind direction? It says mean wind directions are given as bearings, right? Another document here, which is really good, says the same thing. This value is given in degrees relative to true north. So essentially, they are given in degrees bearings. So it's from 0 to 360, right? So because of that, that value of 999 won't work, right? So what we're going to say is for part B, state given a reason what you should do with this value. So you're going to say uh, daily min, daily, daily, what was it? Daily mean, right? And directions are measured as bearings. So I'll write 0 to 360, right? And then you're going to say, since 999 is outside of this range, Keith should remove this value. Right, so it's 2 marks. You get the first mark. You get the first mark for correctly identifying the type of measurement the bearings are, and the second mark is for, well, based on that, what should Keith do? Should remove it. And again, I'll just show you the document. Let me just move this down here so it looks a bit neater. I'll show you the document for the wind directions. You can see here, this column L here, it's all from 0 to 360, isn't it, essentially, right? There's nothing about 999 here, so that is another reason why. So again, for the exam, maybe just have a brief look at this document, the documents in the book, and so on and so forth, just to get a general understanding of each of these. But again, it's quite it's not that many marks, and some people may think it's not useful, but I'll just say just have a general idea of it. But yeah, that is it. That is the answer for question two. 3 marks in the bag. Okay, so question three says customers in a shop have to queue to pay. The partially completed table below and partially completed histogram opposite give information about the time X minutes spent in the queue by each of the 112 customers one day. So we've got the time in queue, X minutes, we've got the frequencies on the right. No customer spent less than 1 minute or longer than 8 minutes in the queue. Part A says complete the table. Okay, so we need to fill in the missing frequencies, and they've told us that there's a histogram underneath. So what I've done is I've actually just cropped that table and information above just on this page here. So firstly, what we need to do to answer the question, let me just zoom out a bit so I can definitely make sure that you guys can see everything clearly. So what we first need to do is label the frequency density, isn't it? And what we can use is the 3 to 4 um row, because we've got that and its corresponding frequency, and we also have the bar given to us. So what I like to do is remember from even from GCSE, the area of a histogram represents the frequency. That has an area of 13, right? 3 to 4 from here. Now, what is the height? Well, that width is a 1, 3 to 4 is 1. This has to be 13, right? And it's exactly 13 squares up, isn't it? So that would mean, let's just zoom in a bit. 5, 10, 1, 2, 3. Yep, 13. So that means each of these goes up in 5. So let's label these up in 5s for now. So let's do that. So that's going to be, this is going to be 5. That's going to be 10, 15, 20, 25, 30, 35. That's going to be 40. Nearly done. 45, 50, 55, 60, 65, and 70. Perfect. Okay, so now we can get going. We need to fill this in. So 2 to 3, that is given to us here. Now that we have the labeling of the frequency density, we just need to calculate this error. That is 1 again. What is that one? Hold on. That is making thing there. Okay, so that's 1 there. What height is that? That's up to 25, isn't it? So this is 25. This area is 25 because it's 1 times the height of 25. So we can put a 25 there, which is perfect. Let me just zoom out so you can see that. Yeah, so 25 goes there. And then we can now figure out what this is, because we know that there are 112 customers. So therefore, the answer for this is going to be 112 minus each of these. So let's do that. Where's my calculator? Calculator's there. We're going to do 112, the total amount of customers, take away each of the other frequencies that we know. 64 minus 25 minus 13 minus 3. And that is equal to 7. So therefore, this must be a 7 there. Okay. So now we're in a position to actually complete this histogram. Excuse me. So, oh wait, what was part A? To just fill in the table. So the table's done. So that's part A, sorry. So part A is done. We're at part A with a tick. So that's 2 marks. And then part B is to fill in the table. So 1 to 2, 64. I remember nobody spends any less than a minute or more than 8 minutes. So we know that we don't have to look at this. This has nothing to do with it. And neither does that. So that's fine. All right. So need a drink of water. 1 to 2, 64. The area is 64. So that means I should go up to 64, isn't it? So we need to go here now, guys. Again, as I said before, OneNote has updated this software, so it's a bit hard for me to actually draw shapes now. So I'm gonna try my best, but let's see how this goes. I'm gonna create an automatic shape, and I need to go to 64, which is around there, and then I need to draw a rectangle. So I'm gonna draw a rectangle. It's gonna be a bit slow, but the idea is that once I draw the rectangle freehand, it will automatically transform into a rectangle, just as long as it's there and about. So I think that looks okay. So do that. Oh, that is brilliant. That is absolutely brilliant. I'm happy with that. I'm very happy with that. Okay. So I just need to put this up a bit. 64 is there. And then put this down like that. That is perfect. I'm so pleased with that. Okay. So that is done. One, two, three. We need to do the 4 to 6. So the frequency is 7, which we know corresponds to the area. So if the area is 7 and the width 4 to 6 is 2, then 2 times what will make 7 3.5. So we need a rectangle that has a width of 2.5, a width of 2, sorry, and a height of 3.5. So I need to go to 3.5 here. So let me zoom in a bit actually now. So 1, 2, 3 is there, 3.5 is that there. So let me draw a rectangle like that. Perfect. That is perfect. So that one is done. And then what's the next one? The last one, 6 to 8. So the frequency is 3, which you know corresponds to the area, but the width is 2. So 2 times what will give me 3? That's 1.5. So now we need a rectangle with a width of 2 and a height of 1.5 to make that frequency of 3, isn't it? So that's just gonna be here, isn't it? So it'll be literally like that. Like that. Oops. See, you got to be careful on this. Draw the trapeze. Let me try again. Let's try again. Let's try again. That better? Yes. Better. Perfect. And yeah, and then what we can do now, we may as well just shade it in grey. So shade it in grey, just like that. And then, whoops, not that one. Like this. If you wanted to, why not? Right, so we just do it like that. No, I won't be too extra. So that looks fine to me. Looks okay. Just make sure looks all neat. I think that's okay. That's reasonable. That's fine. And then this one, let me just make it a bit thinner. It's gonna be like this, like that. And then last one, just make it very, very thin, like that. And that is it. That will be your answer for part A, the completed table, and part B, the complete histogram. So let's go on to part C now. Okay, so part C. Ting decides to model the frequency density for these 112 customers by a curve with equation y equals curve of x squared, where x is between 1 and 8, where k is a constant. Part C says find the value of k for 3 marks. Now, whenever they ask you to find a letter, a variable, a constant, some sort of letter, right, you need to form an equation. That's the main thing that you need to be thinking of. Can I create an equation somewhere, somehow? Now, Ting is modeling the frequency density and they've put that in bold, and that's not for no reason. They've done that deliberately, right? Remember, the frequency density, let's go back to our histogram that we did in part B, right? The frequency density is the vertical axis, right? The x-axis, the horizontal axis is the minutes, okay? Now, since we're modeling the frequency density with this curve, right? K over x squared, we can now just say that this must equal y. Okay, so y is our frequency density, and we still have that horizontal axis of x. Now, next thing is, well, what does that curve actually look like? You should have a good knowledge of your graphs. This curve essentially looks something like this. How do I get the axes again? Yes, from there. And then it's literally going to be like that. This is going to be, whoops, need to get a pen. This is going to be your y-axis. That's going to be your x-axis, obviously. And the graph of y equals curve x squared looks like this, right? Because it's squared, it's gonna lie entirely above the x-axis. If it was just k over x, right, it would look like that, wouldn't it? But it's not. So this is the graph of y equals k over x squared. And more specifically to this question, x is defined between 1 and 8. So I know that I can rub this part out, isn't it? So we're modeling that frequency density, right? Which is corresponding to this histogram with that curve. Now, how does that help us? Remember, we need to form some sort of equation. Think of your histogram. We know that the areas of each of these bars, right? They all sum to 112 customers as was given to us, right? Now, because of that, and the fact that we're modeling this curve with that frequency density, they have to be the same as well. So what I mean by that is the area under this curve here, right? From 1 and 8, from 1 and 8, let's just say it's there. This has to be 112 as well, right? And let's just go back to the histogram very, very quickly, just so it makes even more sense. Let me just highlight this here very quickly. So this is 112, and that actually makes sense because if you look at this histogram, if I was to kind of model it with a curve, you'd probably just start from the midpoints of each of these and you would try and draw a curve. And as you can see here, that pretty much follows the graph of y equals k over x squared, isn't it? Right? So that is just more justification that we definitely need to represent this as an area of 112. Now, remember what I said, we're finding a letter, we need to form an equation. We've got a graph, we've got a curve. We have an area bounded by the x-axis and the curve itself. How do we find the area? Definite integration. So the equation we're going to form is this. We're going to need to integrate this curve, k over x squared, between our limits 1 and 8. And we know what the area must be. It must be 112. And this is the equation that you will form. This is a very good question because it has come up a couple of times. I know for certain it's come up in the A2, the year 13, the actual A-level maths exam for stats. It was question 6, a really good question. I did the walkthrough on it, very, very similar. However, the integration techniques are a bit harder because it's the actual A-level exam. But yeah, it's come up there. And it's come up in an AS paper. I can't remember what year. I thought it was 2023, but it wasn't that one. But it's come up twice from what I know. But yeah, very, very good question where you have to basically relate the histogram to a curve and then find the area by integration. So we need to integrate. Now, remember when we're integrating, we need to make sure we have our integral in the form that we can actually integrate. So what I'm going to do is rewrite that. We know that this is k still. That division of x squared, we can bring it up and then we just put a negative on the power. So kx to the minus 2, and it's still between 1 and 8. So now we're in a position to integrate. So let's go ahead and do that. Integrating that, the k will stay. Add 1 to the power will be -1. Divide by the new power is going to be -1, isn't it? Between 1 and 8. And that will equal 112. And dividing by -1 is the same as multiplying by it. So instead of writing it like that, I'm just going to write it like that. Okay. So now we are here. We just need to evaluate this. Now, this is the easy part, isn't it? So doing that is going to be minus k, 8 to the -1, minus the lower limit, which is going to be minus k, and then 1 to the -1. And this is going to equal 112. So now tidying this up, that's going to be negative k. I'm going to bring that 8 down now, so it becomes over 8. And then two negatives minus minus make a positive. That's going to be plus. And then yeah, it's just k actually, isn't it? Because 1 to the -1 is just 1, so it's just that there. And then this is equal to 112. Now, what is that equal to? So minus an eighth plus 1k. So minus 1 over 8 plus 8 over 8 will leave you with 7/8. So 7 over 8k has to equal 112. And I'll just do it right here. That would mean that k has to equal, we times by 8, and we divide by the 7. So therefore, k is equal to whatever that is. So let's put this into the calculator and see what we get. So 112 times by 8 divided by 7 is equal to 128. So therefore, k has to equal 128. And that is our answer for part C. And yeah, that is it. Finished. Okay, so question 4 says the random variable x is binomially distributed with sample size of 27 and probability 0.35. Part A says find the probability of x equaling 10 for the first mark. That will be 1 mark. Double I will be 2 marks within it. So this is just very, very easy calculator work. So I'm going to get my calculator up. This is a what's the word? It's a point distribution, isn't it? Because it's equal to, not an inequality. So I'm going to get my CG50 up. And yeah, gonna go to binomial. What I'll do is I'll just show you how to do it from the start. So let's just say you're at the menu, you're gonna go down to distribution, which is that one, click execute to get to it, and then you're gonna go to binomial. So yeah, if I go back though, yeah, this is what I meant to look at. So once you go to there, you'll see these three: binomial, normal, or Poisson. Click binomial, so you'll be there. And then now yeah, just plug it in. So essentially it's literally gonna be because it's a point distribution, I'm going to click on this one on our F4 to make it equal. And we're going to plug in x equals 10. The number is 27. N is 27 in this case. The probability is 0.35. So execute. We get that value there, 1.535. So I'm going to just say for part A, whoops, for part A and then I, the probability of x equaling 10 is equal to 0.1535, wasn't it? Which is equal to 0.154. Let's just double check that. Yes, and if you want to just view it, how do you click view again? Always forget F1. Is that it? No. How did it? Oh no, I know what to do. You click option, yes, and then view, yes, and then that is the actual number there. So 1.5358, blah blah blah. So 1.53 4, isn't it, to three significant figures? 0.54. So that's done. Now part double I. I'm normally used to using the class whiz, so I'm still adjusted to the CG50. Anyways, next one. Probability of x being between, sorry, x being between 12 and 15. Now, the 15 is not included, right? And this is a discrete random variable. So, that actually just means between 12 and 14, isn't it, inclusive? So again, you can just put this directly into your CG50, which is what I will do. So CG50 there, I'm gonna go back, which is exit, 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 and then I'm gonna go to exit one more time, execute. I'm gonna now go to, because it's an inequality, joint inequality is going to be this one, F2. And then now I'm going to plug these in. So it's going to be 12. The lower bound is 12. The upper bound is 14, isn't it? And we get that number over there, which is 0 0.7, 0.17. What was that? Is that a 9? Let's check it just to be safe. 0.1794. Let me just write 947 blah blah blah, and then this is equal to three significant figures, 0.179. Perfect. 0.179. And that is it. If you don't have the CG50, maybe you're using the class whiz, then you're gonna have to just do it to the left. So what I'll do is I'll just do it like this. So to calculate that probability, that is just going to be the same as calculating the probability of x being less than or equal to 14, and then you would take away the probability of x being less than or equal to 11, isn't it? Just to get the region between 12 and 14. So 12 is there, 14 is there, and let's say 11 is there, right? You would take away all of these. You would take away everything to the left of 11 from everything up until 14, and that will leave you with that part between 12 and 14. So that's how you would do it if you're using another calculator. But yeah, that is it for part A. So let's go into the hypothesis testing in part B. Okay, so part C and B, I should say, part B and C. It says here historical records show that the proportion of defective items produced by a machine is 0.12. Following a maintenance service of the machine, a random sample of 60 items is taken and 3 defective items are found. Part B says carry a suitable test to determine whether the proportion of defective items produced by the machine has decreased following the maintenance service. You should state your hypotheses clearly and use a 5% level of significance. And this is a 4 marker. Guys, this is a very, very easy 4 marker. Once you do a couple of these questions, it's so easy. You just do the same thing each time. The first thing that you always want to do is you want to set out a null and alternative hypothesis. So I'm going to say H naught. Now, what are we doing? Remember that null hypothesis is what you assume to be true. It says historical records show that the proportion of defective items produced by a machine is 0.2. So we're going to say P is equal to 0.2. Now, H1 is our alternative. What is the alternative? What are we investigating? Let's see. Carry out a suitable test to determine whether the proportion of defective items produced by the machine has decreased. Right? That word is key, decrease. This tells me what type of tailed test it is. It is a one-tailed test because it's going in one direction to the left. Negative. Not negative, less than the probability, I should say. But yeah, it's one-tailed. So I'm gonna say P is less than 0.12. Yeah, less than the null hypothesis. So that is the alternative and null hypothesis done. This will give you 1 mark currently. Now we need to actually define our random variable. We need to calculate it, don't we? So we're going to say D, and this is going to be the number of defective. What are we dealing with? Defective items, right? In a sample of, what is the sample size here? it says random sample of 60 items and a sample of 60, right? That is D. Now we're going to define our binomial distribution. Did I say binomial? I think I did. Binomial distribution. And the sample size is 60. And remember, we always assume the null hypothesis is true. So this is where we're at so far. So you probably get 2 marks so far here. Now, whenever you're doing these types of questions, guys, hypothesis testing, you're always going to have an observed value. And what you need to do is find the probability of observing that value under the null hypothesis, assuming the null hypothesis is true, and you compare this probability, this test statistic, with a significance level. And that is essentially it. Now, what is this observed value that I've been speaking about? Let's have a read of it again. Following a maintenance service of the machine, a random sample of 60 items is taken and 3 defective items are found. Well, in this sample size of 60, we've observed there are 3 defective items. So what I always do is I always write the observed value whenever I'm doing hypothesis testing. The observed value is 3. I need to figure out what the probability of observing that value is. What is this equal to? Right? This is just equal to the probability of a defective item. Now, the alternative hypothesis is to the left, right? It's less than. It's always the same direction. It's going to be probability of D being less than or equal to 3. We need to calculate this probability under these parameters, right? That's literally all we do here. So I'm going to get my calculator and then I'm going to go to binomial, execute, and then I'm going to go to, which one am I going to go to? I'm going to go to F1, and then I'm going to plug in everything that we need. So we're going to say 3, then N in this case is 60, the probability is 0.12, and we get 0.0601, don't we? So this is 0.0, sorry, say again, 0.060. 0601. Now, what we need to do is compare this with the significance level. The significance level is 5%. So what you do from here is you're going to put 0.0601 here. You're going to put 5% here. Now, is this larger than or smaller than? This is larger, right? It is greater than 0.05. What do you do from here? Again, very, very simple. I'm going to call this the value. I'm going to call this probability of observed, right? Probability of observed. I'm just going to give you guys a quick rule. If this probability of observed is greater than your significance level, right? Then you're going to accept the null hypothesis. You accept the null hypothesis, you reject H1. If the probability of your observed value, right, is less than your significance level, then it just flips. You reject H0 and you accept H1. So with that being said, well, we can see that 0.0601 is greater than. So from there, we know that we can reject, or sorry, not reject, we accept H0, reject H1. Now, what you need to do is now put this into context. Now that you know what you're doing, you need to put this into context. So because we're accepting H0, we're assuming that the null hypothesis is true, that the probability of, or the proportion of defective items is 0.12%, or sorry, not 12%, 0.12, right? We're accepting that. And so we're saying that this investigation, right, there's not sufficient evidence that the defective items, the proportion of defective items have decreased, right? We are assuming the null hypothesis to be true. So what we're going to say is to get that mark, to get that final mark, you're going to say there is sufficient evidence evidence to there is insufficient evidence to claim that, or no, let me write this. There's insufficient evidence that supports, this is better, supports the claim that the proportion of defective items has decreased. And that is it. That is what you will get the 4 marks for. So, firstly, identifying your null hypothesis test. Secondly, defining your random variable, defining your distribution. And then the third mark, we put 3 marks here, is for actually finding the observed value, calculating this test statistic, and then comparing it to the significance level, right? And then you get the final mark for actually concluding and summarizing what you've done in the context, right? It's less than it's greater than it's greater than the significance level, which is 5%. So therefore, we accept H0, reject H1. There is insufficient evidence that supports the claim that the proportion of defective items has decreased. And that will give you the 4 marks for this hypothesis test. So that's part B. Part C says write down the p-value for this test, for your test in part B. So part C, again, this is just easy. It's just literally the probability that you get when you calculate it. It's the probability of your observed value. So the p-value is literally just equal to that number there. 0.0601, or if they want it to free significant figure, 0.06. And that is it. That is question 4 finished. Okay, so question 5 says a biased four-sided spinner has the numbers 6, 7, 8, and 10 on it. The discrete random variable x represents the score when the spinner is spun once and has the following probability distribution. So we've got the table, we've got the set of x values 6, 7, 8, and 10, and then we've got the actual probabilities for each of these, which are 0.5, 0.2, q, and q, where Q is a probability. Part A says find the value of Q, and this is 1 mark. Reason why it's 1 mark is because remember when you're dealing with a table, all probabilities must sum to 1. So what we can do is we can create an equation in terms of Q to solve. So let's do that here. So part A, again, whenever you see find the value of Q, any letter, you have to form an equation. So the equation that we're forming is going to be the sum of the probabilities being 1. So it's going to be 0.5 plus 0.2 plus Q. This has to equal 1. That is 0.7. That's 2Q. That's 1. So therefore, moving at 0.7 over, it's going to be 2Q is equal to 0.3. And so therefore, Q is going to be half of that, which is 0.15. Right? So, yeah. Q is equal to 0.15. So that's part A. Part B, it says Karen spins the spinner until she either gets a 7 or she has taken 4 spins. Part B says show that the probability that Karen stops after taking her third spin is 0.128. And this is 2 marks. Okay. So let me just crop this and bring this underneath. And then we can just work with it. But again, this is not too bad. Straightforward. So, how can you stop on your third spin? Remember, she either stops until she gets a 7 or she's taken 4 spins. So if she stops on her third spin, that means she couldn't have got a 7 on the first or second go. So what I'm going to do here is say the probability of her stopping on her third spin, right? Well, this would have to be just from a logical perspective. Um, she couldn't have got a 7 on the first go. So I'm going to write not 7 here on the first go. And then on the next go, I'll put and here because remember it's all independent. You're going to have a not 7 again, right? And then on the third go, because she's stopping, we know that she stops until she gets a 7 or has taken 4 spins. So she must get a 7 on the third go. So this is the only way she can stop on her third spin. So the question is now, what are these probabilities? Now, what is the probability of you not getting a 7? Well, if you get a 7, it's 0.2. So not a 7 is 1 minus that, isn't it? Which is 0.8. So therefore, it's going to be 0.8 here. 0.8 there. It's going to be 0.8 for that one. And then probably if you get in a 7 was 0.2 as we saw. And remember, and is just multiplication. So the answer is just equal to whatever this is equal to. So let's get the calculator out and put this in. So doing that there, it's going to be 0.8 times another 0.8 times a 0.2. And this is equal to 0.128. 0.128 as required. And that is it for part B. Let's go into part C now. Okay, so part C says the random variable S represents the number of spins Karen takes. Part C says find the probability distribution for S for 4 marks. Now, whenever they ask you to find a probability distribution, guys, remember you're just constructing a table of the probabilities. Very, very similar to what we have in part A, right? The actual question. So what I'm going to do is we're dealing with the random variable S. So I'm going to construct a table. Let me get a ruler. So let's just say, let me just put this like this, like that. I'm going to just draw a vertical line like that. And then I'm going to just rotate this ruler to be horizontal. Yeah, like that. And then just going to put it down a bit like that. And then I'm going to just draw a horizontal line like that essentially. And then let me get rid of the ruler. And I'm going to say this is lowercase s, and this is the probability of s equaling s, right? Now, remember, s is the number of spins Karen takes. So how many spins is she going to take? Well, remember, she's playing this game, and as you can see, I've actually got part B here underneath just to give us the context again. Karen spins the spinner repeatedly until she either gets a 7 or she has taken 4 spins. So she takes at most 4 spins, isn't it? So she's going to have to take at least 1 spin to play the game. So it'll be 1, 2, 3, or 4, isn't it? And then that means I can just rub a lot of that out, to be fair. So that might as well do that. Let me just rub a bit of this out. Okay. Now, how do we calculate these probabilities? Remember what we did in part B. Karen spins the spinner until she either gets a 7 or she has taken 4 spins. Show that the probability that Karen stops after taking her third spin is 0.128. So we can put that there, isn't it? Right? Because she stops after the third spin if it's at s equals 3. So we've done that. Now, how did we calculate this again? Remember, the probability of s equaling 3, right? How does that happen logically? She must miss a 7 on the first and second go, which would mean that it's going to be 0.8 times 0.8. And then she must get the 7 on the third go, which is 0.2. Just to remember what we did here, not 7 was 0.8, not 7 0.8, 7 was 0.2, right? Just based on this probability table here. So, continuing, what do we have? So we need the probability of s equaling 1, right? That means that she stops on the first go. Well, for her to stop on the first go, that must mean she gets to 7, isn't it? And the probability of you getting a 7, we know is 0.2. So that can go there. And now to get the probability of s equaling 2, right? Meaning that she stops on the second go. Well, that would mean that she would miss the 7 on the first go, which is 0.8. And then she must get it on the second go, which is 0.2. And that there is just 0.16, isn't it? So that can go there. And then now to get the probability of s equaling 4, there's 2 ways to do it. I'm going to do the most straightforward way, but I'll do the other way just because it's really good to understand the logic behind it. So we just add those up and then take it from 1. So I'm going to get my calculator. I'm going to do that there. So that's just going to be 1 minus 0.2 minus 0.16 minus 0.128. And this is equal to 0.15, 0.512. So that is our complete probability distribution. However, what I would say is the other way that you could do this, which is really good for your understanding as well, to say, well, what is the probability of s equaling 4, right? If you were to think about it, how would you compute that? Well, s equaling 4 means that you've spun it 4 times. So the question is, how could you spin it 4 times? Are there multiple ways? There are. The first way is, well, if I get the 7 on the fourth go, and that would mean I'd have 0.8 missing the 7 on the first, 0.8 missing on the second go, and then 0.8 missing on the third go, and then eventually getting it on the fourth go, right? That is one way you can get 4 spins. Or how about you just don't get a 7 at all? That's not an impossibility, right? You can just spin it 4 times and not get a 7 whatsoever. And that would just be 0.8 to the power of 4, isn't it? Right? So this here must be the same as that. And what you can do is let's just try it and see if we get the same thing. So let's put it into our calculator. So we're going to do 0. Remember, or is a plus, by the way. Let me put a plus there, right? We know that or means plus. So the probability of s equaling 4, which we know is 0.512, should be the same as 0.8 cubed times 0.2 plus 0.8 to the power of 4. Let's see if that's the same thing. So 0.8 cubed, where's the power on this thingy here? You just press that? Okay. And then times 0.2 plus 0.8 to the power of 4, the exact same thing. So that's how you know it works, right? So you can do it this way. I've seen a question like this in the Edexcel book. So have a look at the AS book for Edexcel. And then the discrete, I think it's chapter 5 or 6, I can't remember, but it's just before the binomial distribution part. There's a couple of questions that's an exercise. So that is the answer for part D. That is done. Now, let's go into part C. Okay, so part D says the random variable n represents the number of times Karen gets a 7. Part D, for 1 mark, says find the probability of S being greater than n. Okay, now remember, what is S equal to? Let's have a look at the questions that we've been seeing. So remember, Part C says the random variable S represents the number of spins Karen takes, and N is the number of times Karen gets a 7. So what I would do is just think about this from an English perspective. I would get rid of the letters and think about what the actual letters represent. So I'm going to say S just from the top of the page. S represents the number of spins Karen gets. So I'm going to call that the number of spins. The number of spins. And N from here is the number of times she gets a 7. So number of times, all right, just Karen gets 7. So for me, the question is asking me to find the probability that the number of spins is greater than the number of times she gets a 7. Well, how can she get a 7? Remember this game. She spins the spinner repeatedly until she gets a 7 or she has taken 4 spins. So the moment she gets a 7, she stops. So it's not like she can get multiple 7s in this game or this scenario. She gets a 7 and then she stops. So for me, the way I look at it is that the number of times she gets a 7 can only be 1, right? It can't be more than 1, because once she gets that 7, she stops the game. So for the number of spins, right? Let me write this here. So let me write S is greater than N, right? So for the number of spins to be more than the number of times she gets a 7, she must miss the 7 on the first go. That is the only way, because if she gets on the first go, the number of spins once will be the same as the number of times she gets that 7 once, right? So for this scenario to be true, she must spin the spinner more than once because she misses the 7 on the first go. So let me write this in long English terms. So we're going to say number of spins is more than number of times. All right, Karen gets 7. Now, how does that happen? Again, as I said before, she just has to miss the 7 on the first go. And if she misses the 7 on the first go, it means that she either gets it on the second, or she gets it on the third, or she gets it on the fourth go. So what we can say is that the probability of S being greater than N is just the same as the probability of S being greater than 1, which is going to be equal to the probability of S equaling 2, or the probability of S equaling 3, or, hold on, that should be a bracket, or the probability of S equaling 4. And that there is just going to equal, I'll write it out just because I've done it like that, 0.16 plus 0.128 plus 0.1512. But that is just the same as 1 minus 0.2, isn't it? So I know that's 0.8, like that. Or you could have just written it like this, 1 minus 0.2, which is also 0.8. So the answer is 0.8. And that is it. And that is it for the stats paper. Okay, so question 1 says, figure 1 shows the speed time graph for the journey of a car moving in this long queue of traffic on a straight horizontal road. At time t equals 0, the car is at rest at the point A. The car then accelerates uniformly for 5 seconds until it reaches a speed of 5 meters per second. For the next 15 seconds, the car travels at a constant speed of 5 meters per second. The car then decelerates uniformly until it comes to rest at the point B. For the total journey time is 30 seconds. Find the distance AB for part A, and this is 3 marks. So we're dealing with a speed time graph. What you should always remember is that the distance is always just the area underneath the graph. What are we dealing with here? We're dealing with a trapezium, aren't we? So what we want to do is just essentially work out the area of this trapezium. So firstly, what are the dimensions? You know what, I'll do it here. So part A, we just need to work out the area of that trapezium. So let me get a trapezium going. And then we just need to figure out the dimensions and then use the formula. So what do we have? It goes from 0 to 30 because that's the time. So that's just 30 at the bottom. At the top, 5 to 20 is 15. So we're going to put a 15 there. And then the vertical height is just the speed it goes up to, which is 5. So we have that there. So the area of a trapezium, we know is just 1/2 times A plus B times by H, isn't it? So in our case, it's just going to be equal to 1/2 times by 15 plus 30 times by 5. So putting that into my calculator will give me 1 over 2, and then bracket 15 plus 30, and then times by 5. And that is equal to 225 over 2, which is 112.5. Where is SD on this? Right there. Perfect. 112.5, and it's in meters, isn't it? So that is part A. Part B, it says sketch a distance time graph for the journey for the car from A to B. So a distance time graph, we have the speed time graph, isn't it? So you can just think of it as you going one above. So remember, you always have you have the displacement or distance, and then you have the speed and you have the acceleration, right? So we're going up one, right? If you're thinking it from a calculus perspective. So all we're gonna do now is say, okay, let's get an axis going, which I can get from over there, and then let's say it looks like that. Okay, and then we're gonna call this the distance. This is gonna be the distance axis here. This is gonna be the time axis here. Now we know the distance it travels to. It goes to 112.5, so I can put that there. And then essentially, what we want to do is just essentially draw what this graph will look like throughout its journey. So let's start with the first part of the journey, which is the first 5 seconds. So we know that the speed is the gradient of the distance time graph. The gradient, right, goes from 0 to 5, doesn't it? Right? Because the speed goes from 0 to 5. So how does that reflect on our distance time graph? It's going to be a curve, isn't it? Because it starts from a gradient of 0, the speed 0, going up to 5. So between 0 and 5, what we can say that between 0 and 5, so let's say 5 is there, it's going to look like a curve like that. It's going to curve up like that, essentially. Let me just do it a bit lower. So let's just say it's like that. That is for the first 5 seconds of the journey. And what distance does it travel in those first 5 seconds? It's just going to be the area of this triangle, which is going to be half times 5 times 5, isn't it? 5 times 5, which is going to be 12.5, isn't it? Half of 25. So we can just say this is 12.5 over there, and then that is the first 5 seconds of the journey. Now the next 15 seconds, 5 to 20, right, the speed is constant, it stays the same, right? So how does that reflect on our distance time graph? If this speed is staying the same, it will have to be a straight line, isn't it? Right? So for the next 15 seconds, so let's just say, for example, 5 to 20, we're gonna have a straight line, aren't we? So if I get my ruler, and then I'll try and see if I can do something with that. Maybe like that. It's quite hard to use these rulers now, but we'll see. So let's just say it's like that, straight line like that for the next couple of seconds. Let me get rid of the ruler. And then what I'll do, just for the purpose of this diagram, I'll put it like that there. And essentially what we're saying here is that the gradient of this straight line is 5, isn't it? Because that's what the distance is. I need to rub this out a bit to make it a bit. So let me do point eraser and then just go like that. Okay. And now, just put it a bit up. Okay. And then now, you know what I'll do? You know, I'm going to just do this. It's just so hard to use. Let me just do it like this here. I think this is better. So that is going to be 20. Like that. And then the last 5 seconds of the journey, right? Or not the last 5 seconds, sorry, the last 10 seconds, right? The speed is going from 5 to 0. How does that reflect on our distance time graph? Well, the gradient is changing, so it has to be a curve, but it's going from 5 to 0. So it's going to curve downwards, isn't it? So it's going to be like this. So it's going to be like this, essentially. And then this will be 30 seconds here. And yeah, that would be the answer essentially. And then what you could do, just to really bring it home, what distance did it travel in those 15 seconds? It's going to be the area of this rectangle, which is 100, isn't it? 100. Oh no, sorry, no. 5 to 20 is 15, like that. That is 5. 15 times 5 is 75. The area here is 75. So we're going to do 12.5 plus 75, which is going to be 87.5, isn't it? And yeah, that will be it. This will be your answer for part B. And that's it. That's question 1 finished. Okay, so question two says a particle is moving along a straight line. At time t seconds, t is greater than zero. The velocity of the particle is v meters per second, where v is equal to 2t minus 7 root t plus 6. Part A says find the acceleration of the particle when t is equal to 4 for 3 marks. Okay, so again, this is just variable acceleration. Remember, let me just put part A here. You always have three things. You've got displacement, you've got velocity, you've got acceleration. If you're going down, you differentiate. I'll just write dy dx. If you're going up, you integrate. So we want the acceleration and we're currently at velocity. So all we need to do is just differentiate with respect to t to figure out what the acceleration formula would be. So I'm going to write this. V is equal to 2t minus, and then instead of writing root t, because I'm differentiating, I want to express it as a power, I'm going to write as t to the power of a half, and then plus 6. Perfect. And then now, I need to differentiate this to get acceleration. So I'm going to say dv by dt, which I know is equal to the acceleration, is going to equal, that will just become a 2. The half will drop to the front, so it'll be 7 over 2 t, and then it would be to the minus a half. If I take 1 away from that power, and the 6 will just become nothing. So this is our acceleration formula. It's our formula for the acceleration. We want the acceleration of the particle when t is equal to 4. So all we're going to do now is plug in t equals 4 into that and see what we get. So it's going to be 2 minus 7 over 2, and then it's going to be 4 to the minus a half. So let's put that into the calculator and see what we get. So it's going to be 2 minus 7 over 2, 7 over 2, and then 4 to the minus a half. Where's the power? Where is the power again? I'm not used to this calculator. I can't even find out. I'll just do that and then I'll just change it. Minus a half. Okay. So like that, and then you get 0.25. So the answer is 0.25. And that is our answer for part A, the acceleration of the particle when t is equal to 4. And that'll be in meters per second, isn't it? So let's just write that as well. Why not? Perfect. So that's part A. Okay, so part B says when t is equal to 1, the particle is at the point x. When t is equal to 2, the particle is at the point y. Given that the particle does not come to instantaneous rest in the interval between 1 and 2, show that xy is equal to a third times 41 minus 28 root 2 meters for 4 marks. Okay, so firstly, we're dealing with a distance, isn't it? Right? We need to calculate a distance. Remember, this is variable acceleration. Remember what I said before? We've got the displacement here, we've got the velocity here, we've got the acceleration here. To go down, we differentiate. To go up, we integrate. So I've just got what we were given in part A, the velocity, right? Because we're looking for a distance, which is essentially the displacement, we're going to go up. So we're going to go from V to S by integrating. So this is an integration problem, first of all. Now, secondly, it says that it does not come to instantaneous rest, right? In the interval 1 to 2. This is very, very important because a lot of the times when you do these types of questions, maybe a part A would be finding the points or the times when the particle does come to instantaneous rest. And what does that actually mean? It means that the particle is changing direction. How does that affect your integral or the geometric interpretation of it? What will happen is that if you're integrating between two limits and your particle changes direction, then the point it changes direction would mean that the displacement will be negative. So when you have a particle changing direction, when it does come into instantaneous rest, you have to split it, right? But the fact that it says that it doesn't means that you can just integrate directly from 1 to 2. So that's the main thing with this one. So essentially what we need to do is just literally integrate this expression here, 2t minus 7, and I write t to the half again, plus 6 dt, between 1 and 2. And that's it, due to the fact that it doesn't come to instantaneous rest anywhere in that interval. If it did, then you'd have to split it into different parts and then add them together. Perfect. So all we need to do is just integrate that. So let's go ahead and do that. That is going to be, firstly, that's going to be 2t squared divided by 2. We add 1 to the power, divide by the new power. This is going to be minus 7t to the power of, if I add 1 to that, it will be 3 over 2. And then we're going to divide by the 3 over 2. And then plus, and that will be 6t, wouldn't it? And then because it's a definite integral, we don't need to put a plus c between 1 and 2. So let us, before we do anything, let's just tidy this up a bit. 2 divided by 2 is just 1, so that's just going to be t squared. Minus, and then it's going to be 7 divided by 3 over 2, which is the same as times and by 2 over 3. So that's going to be 14 thirds, isn't it? Right? 7 divided by 3 over 2 is 14 thirds. You can put in your calculator. And then t to the 3 over 2 plus 6t. And this is between 1 and 2. Now we need it in a certain form that there. So let's evaluate and see what we get. So we're going to have, plug it into, it's going to be 2 squared minus 14 over 3. And then it's going to be 2 to the 3 over 2. And then plus 6 lots of 2. And then minus the lower limit, which is going to be 1 squared minus 14 over 3 times by 1 to the 3 over 2 plus 6 lots of 1. Okay, so let's work that out and see what we get. So if I put this into the calculator directly, hopefully it will give me a certain and I can just evaluate it and then work it out. So it's going to be 2 squared, which I know is 4, but I'll just write it like that just so I know it's super clear. 14 over 3. And then 2 to the 3 over 2, which is going to be like that. Oh yeah, you just do that, don't you? Duh. And then like that. So let me just double check. That looks good. That's the upper limit. That is fine. And then plus the 6 times 2. And it gives us that there. So it does it for us, which is great. So it's going to be 48 minus 28 root 2 over 3. Over 3, that's fine. And then minus, and then this one is going to be, let's have a look here. That's going to be 1 minus 14 over 3. 1 squared is 1. 1 to the 3 over 2 is just 1. So that's just going to be 14 over 3 and then plus 6. Because it's just 1, isn't it, that we're plugging in. So we get that there. So we get 7 over 3 for that. So now we have that for both of them. What do we get? So all we have to do now is just show that we get 41, which is absolutely fine because they've got the same denominator. So we can actually write like this: 28 root 2 minus 7 all over 3. And then 48 take away 7 is 41. So because 41 minus 28 root 2 over 3. And then that division of 3 we can take out as a factor of a third, isn't it? So we get that. And then we get 41 minus 28 root 2. And that's exactly what they wanted. And that's part B finished. Okay, so question 3 says, a particle P is moving on a smooth horizontal surface under the action of 2 forces. Given that the mass of P is 2 kilograms, the 2 forces are 2I plus 4J newtons and Ci minus 2J newtons, where C is a constant. The magnitude of the acceleration of P is root 5 meters per second. Find the 2 possible values of C for 5 marks. Okay, so we're trying to find 2 values for C. Right now, whenever you're trying to find the value of a letter, in this case a constant, you need to form an equation here. Now, what comes to mind for me when I look at this? I can see mass, I can see forces, I can see acceleration. There's only one topic this is going to be. It's going to be F equals ma, the thing that connects all of these 3 together. Mass, force, acceleration. F is equal to ma. So this is what I'm going to use to try and answer this question. Now, what do I know? In F equals ma, that F represents the resultant force, doesn't it? So I'm going to write resultant force. So what I want to do is calculate what that would be. Now, to calculate the resultant force, you just sum the 2 forces together. So I'm going to do 2I plus 4J plus Ci minus 2J. Now, doing that is very, very easy. The 2I plus the 2I plus the Ci, we can just write as 2 plus Ci, isn't it? Right? Just in terms of the I components. And then obviously the 4J minus 2J is just a plus 2J. So that is the resultant force. Now, the acceleration is given to us, right? The acceleration is root 5. Now, they've told us the magnitude of their acceleration is root 5. This is a scalar here. So what I actually want to use, just because I don't know I don't know the direction of the acceleration, I just know the scalar of it, the magnitude, I'm going to use the scalar version of F equals ma. So I'm going to do this. I'm going to say the magnitude of F is going to equal the mass times the magnitude of A. Reason being is because I have the magnitude of the acceleration and I can calculate the magnitude of the force, the resultant force, by just doing the Pythagoras of these components. So all we're going to do is just plug everything in now. So if that is F, the resultant force, I'm going to select the magnitude of F then is just going to equal the Pythagoras of those two. So 2 plus C all squared plus 2 squared, right? We know what M is. M is equal to 2. The mass of P is 2 kilograms. So M is 2 and A is equal to root 5. So that is root 5. So with that being said, to be fair, I should put it there as well, actually. So with that being said, this here just becomes the square root of 2 plus C all squared plus 2 squared, and this is going to equal the mass, which is 2, and the acceleration, which is root 5. And now we just have to solve this and see what we get, right? So squaring both sides is going to get rid of the root. So it's going to be 2 plus C all squared plus 2 squared. And then you got to be careful. If I square both sides, if I square this, let me do it here so it's super clear. 2 root 5 all squared is just going to be 2 squared times root 5 all squared. 2 squared is 4. Root 5 all squared is 5. So it's 20, isn't it? So that is a 20 here when I square both sides like that. Okay, so now we're here. What can we do? Well, firstly, I'm going to move this. Let me write this as 4. So 2 plus C all squared plus 4 is equal to 20. Move the 4 over. I'm going to get 16 on this side. I'm going to have 2 plus C squared on that side. Square root both sides. So I'm going to have 2 plus C is going to equal the square root of 16, which is 4, but plus or minus. And then now that just means that C is going to equal, if I move that 2 over by taking it away, it's going to be minus 2 plus or minus 4. So either C is going to equal minus 2 plus 4, or C is going to equal minus 2 minus 4. Minus 2 plus 4 is just 2. Minus 2 minus 4 is minus 6. So the two answers for C, the possible values are C equals 2 or C equals minus 6. And that is it. That is question 3 finished. Okay, so question 4 says, Figure 2 shows a car towing a trailer along a straight horizontal road. The mass of the car is 800 kilograms and the mass of the trailer is 600 kilograms. The trailer is attached to the car by a tow bar, which is parallel to the road and parallel to the direction of motion of the car and the trailer. The tow bar is modeled as a light rod. The resistance to the motion of the car is modeled as a constant force of magnitude 400 newtons. The resistance to the motion of the trailer is modeled as a constant force of magnitude R newtons. The engine of the car is producing a constant driving force that is horizontal and of magnitude 1740 newtons. The acceleration of the car is 0.6 meters per second, and the tension in the tow bar is T newtons. Using the model, part A says show that R is equal to 500 for 3 marks. So I've just got this summarized here. So this is a connected particle question. Whatever you whenever you do these types of questions, what you should always do first is label your force diagram. So let's get going. Now, let's read it sentence by sentence. The mass of the car is 800 and the mass of the trailer is 600. So what you could do, which is good practice, is to just put the weights there. So that's going to be 800 G and this is going to be 600 G, like that. That's always good practice. You have reaction forces up here, but I'll just put vertical lines here because we're not dealing with vertical motion here, so we don't really need it. But I'll put the arrows there anyway. And then let's get to the nitty gritty. The trailer is attached to the car by a tow bar, which is parallel to the road and parallel. So the tow bar has tension in it, doesn't it? It says at the very end, the tension in the tow bar is T newtons. Now, whenever you're doing these types of questions specifically, you're literally just going to have the tension going like that and the tension going like that. And you're going to have a T here, you're going to have a T there. Perfect. Now, smooth road. There's nothing about friction. The resistance to the motion of the car is modeled as a constant force of 400 newtons. So we're gonna have a 400 newtons force. I'll just do it. Should I do it like that? I'll just do it there. Why not? So 400 going that way. It's resisting the car. What else do we have? The resistance to the motion of the trailer is a constant force of R newtons. So we're gonna have an R going like that. And then the engine of the car is producing a constant driving force that is horizontal and of magnitude 1740. So driving force is going to be going to the right, and this is going to be 1740. And the acceleration of the car, which I'll call A, right, is equal to 0.6. And I'll just do arrows like this. You know what I'll do? Let me just do this. Whoops, that was an accident. Let me just get rid of, that's not let me rub it out. That is very, very odd. Anyways, if it's not letting me rub it out, I'll just do it like this. 0.6 and then meters per second. And then the two arrows to indicate the acceleration going that way. Okay, now our force diagram is done. We need to show that R is equal to 500. So whenever you do these types of questions, connected particles, it's literally F equals ma. So what you can do is two things. You could either treat this as an entire system, or you could split it, right? So what I'm going to do is I'm going to treat it as an entire system to figure out what R is. So I'm going to write F equals ma for entire system. Entire system. Whoops. Entire system. Okay, so hold on. That doesn't look nice. Let me rub that out. Let me write entire system. Okay. So with that being said, that's not any better to be honest. But anyways, if we're treating this as an entire system, then what is the driving force? The driving force is this one. What is the resistance to motion? It's going to be that one there. The two t's in the middle are going to cancel each other out, aren't they? So we're not gonna include that. So essentially, it's just going to be 1740 r and this force here as well, isn't it? This 400. So the F and F equals ma is literally going to be, I'll do it here, it's going to be 1740 minus that 400 minus that r, and this is going to equal the mass of the object. Now, because we're treating it as an entire system, it's going to be the masses of both the car and the trailer, which is going to be 800 plus 600, which is 1400, isn't it? So it's going to be 1400 for the mass, and the acceleration we know is 0.6, so I can put that there. And now we have an equation in terms of r, which we can solve. So let's go ahead and do that and see what we get. So I'll do it here. I'll do it. I'll just do it here. So it's going to be, that's 1340, isn't it? Minus r, and that is equal to 1400 times 0.6. What is that equal to? 1400 times 0.6 is equal to 840. So I get 840 there, and that means that 1340, if I move that over there, add that there, it's going to be minus 840 is equal to r. That means that r is equal to 1300 take away 800 is just 500, isn't it? So we get R is equal to 500. And that is part A. Part B, I think I've got it down here. Yes, part B says find the value of T. That is the tension in the tow bar, isn't it? So if we go back to our force diagram, now we can treat it, we can separate them, right? So we could either, I'm going to just draw a vertical line down there. You could either use F equals ma for the trailer or F equals ma for the car. Doesn't matter. I'll use F equals ma for the trailer, because there are fewer forces to work with. So I'm going to use F equals ma for the trailer. So if I do that, so I'm going to say F equals ma for the trailer. Well, let's look again. The tension is driving it forward. The R is resisting it. So it's going to be T take away R, isn't it? So it's going to be T minus R is equal to the mass of the trailer, which is 600. And the acceleration is 0.6, isn't it? Now remember, we know what R is. R is equal to 500, so I can put that in as well. So I've got T minus 500 is equal to 600 times 0.6. And what is that equal to? So what is that? 6 times, what's that? That's 6 over 10. 6 times 6 is 36. 100 divided by 10 is 10. That's 360, I believe. And then that's T minus 500. And that just means then that T is going to equal 360 plus 500, which is just 860. And that is the answer for part B. So T equals 860 newtons. And now let's go into part C now. Okay, so part C says, at the instant when the speed of the car and the trailer is 12.5 meters per second, the tow bar brakes. The trailer moves a further distance d meters before coming to rest. The resistance to the motion of the trailer is modeled as a constant force of magnitude 500 newtons. Using the model, show that after the tow bar brakes, the deceleration of the trailer is 5.6 meters per second for 1 mark. Okay, so whenever you're doing these types of questions, it's very common where the first part of the question is where the particles are connected, and then the second part is where they talk about the tow bar brake, and then they go in their own ways. So what I like to do is I like to think of these as two phases of motion, right? The first phase is when the particles are connected. The second phase is when they are disconnected, essentially. And based on the disconnection, you'll have different formulas in terms of F equals ma and so on and so forth. So let's see what we do here. We're looking for the deceleration of the trailer. So at the moment, the tow bar breaks, right? Let's visualize that. So what I like to do is I'm going to draw another diagram. So this is going to be my trailer. And then what I know, can I draw this so it looks like a rectangle? I think so. Let's try again. My trailer here, good stuff. And then what I like to do is I like to just draw the tow bar, but it's broken. Whoops. Let me do it like that. So it's broken, right? And then what else have they said? They've told us that the resistance to the motion of the trailer is 500. So it's still 500. So that's 500 over there. And what else do we know? We know, I'm going to call this phase two, by the way. Let me call this phase two. This is phase two when they're disconnected. This is phase one. This is phase one. Okay. Now we are looking for the acceleration after it is broken. What is this equal to? So what we're going to do is essentially just F equals ma, isn't it? So what I think is good to do as well, which one of my students likes to do, shout out Jack. When there is no driving force, you can just write this as a zero, couldn't you? Right? And so therefore, if I was to use F equals ma on the trailer, it's going to be zero, right? Minus the 500 is going to equal the mass of the trailer, which we know is 600, and the acceleration is what we're trying to calculate. So we are here. So that means we've got minus 500 is equal to 600a. That means that minus 500 divided by 600 is equal to a. That means that the acceleration is minus 5 over 6 because the hundreds cancel, don't they? And that is the acceleration, right? Remember, the question asks for the deceleration. So it's the same thing. And then a negative acceleration is the deceleration. So what we can say then is therefore, the deceleration is equal to 5 over 6. And that is it for part C. Now, part D says find the value of D. D is the distance. Let's read that sentence again. The trailer moves a further distance d meters before coming to rest. So again, remember, we're treating this in two phases. We're looking at phase two, the moment the tow bar breaks. What do we know about this? Let me move this down here a bit, and then let's plug in what we know. So we figured out the acceleration when this happens is minus 5, 6. So let me rub that out and put minus 5. Let me do it like this. I'm going to write this like this. I'm going to write phase two here, phase two, and then the acceleration is minus 5 over 6, and it's going that way. Whoops, sorry. That's better. Okay. And we're looking for the distance d. So the trailer moves a further distance d before coming to rest. So let's just say I was to draw a horizontal line like that. Hold on. Let me get a ruler. Make it horizontal, and then just bring it down like that. Okay, now it's okay. That is better. Up a bit, perfect. And then if I was to just draw a line like that, then essentially what we're saying here is that this is a distance of d, and when it gets there, right, it stops basically. And well, what do we know? Remember, at the instant when the speed of the car and the trailer is 12.5 meters per second, the tow bar breaks. So the moment you finish phase one and you're at the start of phase two, the trailer and the car have a speed, right? And that speed is 12.5. So what we can actually say here is that our initial speed at the beginning of phase two is 12.5. So I can put that there. And then if it gets to rest, what would the speed be? It would be zero, isn't it? So I can say V is equal to zero. So essentially this is just Subat, right? So we need to figure out what D is. So let's write our the variables that we know. We know U equals 12.5. We know that it finishes with a speed of zero because it's at rest. We know that the acceleration is minus 5 over 6. And we're looking for S, which in this case is called D. So what Suvat formula connects U, V, A, and S together? That's just V squared equals U squared plus 2AS, isn't it? So we're going to say V squared is equal to U squared plus 2AS. And now we're just going to plug in everything. So it's going to be 0 squared. It's going to equal 12.5 squared. Plus 2 lots of a, which is minus 5 over 6 times by s. So working that out, that's 0. Don't know what that is. Let me put it in my calculator. That's going to be 12.5 all squared. It's bigger than 144. That's what I know. 156.25, or as a fraction, 625 over 4. So that's 625 over 4. That is going to be minus 2 times 5 is 10 divided by 6. That's 5/3, isn't it? 5 over 3 S. So you know what, yeah? Because I've called it D, S is equal to D, I'm going to write a D instead, aren't I? Let me write D. Even though it doesn't really matter. I'll put D there. And then that means if I move that over, 5/3 D is going to equal 625 over 4. So therefore, D is equal to 625 over 4 times by 3 over 5, isn't it? And that is equal to, I'll just do answer. So shift and then answer times by 3 over 5. And that is equal to 93.75. So 93.75 meters. And that is it for part D. Let's do part E now. Okay, so part E says, in reality, the distance d meters is likely to be different from the answer found in part D. Give two different reasons why this is the case for 2 marks. So this is just those modeling questions at the end of a mechanics question, right? And all you're doing essentially is just looking at what they've told you has been modeled and just negating it, right? So let's read through this bit of information. Mass of the car, that's fine. Trailers attached to the car, parallel bar, that's fine. The tow bar is modeled as a light rod, right? In reality, would the tow bar be light? There will be a weight, right? So that could be one thing. The resistance to the motion of the car is modeled as a constant force of magnitude 400. Who says it's going to be constant throughout the entire journey? Things could change, right? The resistance to the motion of the trailer is modeled as a constant force. Again, that could change. The engine of the car is producing a constant driving force that is horizontal and of magnitude 1740. Why would the driving force be constant throughout? Maybe you're braking, maybe you're accelerating. It's not going to be a constant force, right? These are the things that you're looking at and you just literally negate it. Another thing is the acceleration of the car is 0.6. Who says it's going to be constant? So you just literally just pick one of two of these things and just write them, and then that will give you your answer. So I'll just write here. So the first one I can say is the tow bar being modeled as light. So I could say in reality, in reality, the tow bar will not be light, right? In other words, you need to account for the weight of the tow bar, essentially. So that's one. Another one is the driving force, right? In reality, in reality, in reality, the driving force, I'll write in brackets 1740 newtons, will not be constant. And that's literally it. Any of these two model assumptions you just negate, and then those will give you the 2 marks. The mark schemes has quite a few of them, but yeah, that's literally, and that is the mechanics part of the paper finished. Okay, so that's it. That's the end of the paper. So I hope you guys found it helpful. There were a couple of maybe curveballs in there, but I think overall, largely, it was an okay paper, especially for the AS students. But yeah, I'm sure that you guys are in a good position anyway. You guys are studying hard, you're watching videos, you're revising every single day, so you guys will be fine. But yeah, any questions in this paper, I'm hoping that this walkthrough has clarified things for you and you're feeling more confident for your mocks and obviously when you do your exams, whenever that will be. So yeah, that's pretty much it. Couple of things. I will be running some live group classes throughout the whole of the academic year. So if that's something you'd be interested in joining, then you just go to my website, MathsWithDan /courses. I'll put all of the links in the description as well, just in case anybody's interested. But yeah, most importantly, I'm hoping that you find this video helpful. If you did find it helpful, it's always appreciated if you like, comment, and subscribe. Share with any of your friends, anyone that you think will be interested in these videos. But yeah, until next time, keep studying hard and I'll see you guys soon. Take care. Bye bye.